Welcome to today's webinar. The topic today is most frequently asked questions answered by Dlubal support team, our regularly presented webinar. My name is Andreas Sörold. I'm responsible for marketing and public relations in the company Dlubal Software. For instance, the content of the website, the German and English webinars, the customer projects, newsletters, and so on. I will be the moderator today, and I present the first part of the webinar, and then I hand over to Jürgen. Jürgen can introduce himself.
Yes, thank you, Andreas. My name is Jürgen Teilmann. I work for Dlubal mainly in customer support. So this is where I answer your questions about using the program, whether via email or via telephone support. And within this function, I regularly browse through all the questions that come and filter for the most frequently asked questions and prepare this webinar. Like Andreas said, I will be presenting the second part of this webinar, and in the first part, I will be answering your questions, while in the second part, Andreas will be answering your questions. So that's all from my side for now. Back to Andreas.
Okay, thank you. Then we can switch off our webcams so that the attendees can see the full screen. So you can ask questions via this part of your screen or of the window. You have to press this button above, and then you can enter a question here. And one of us will answer you. And you can also adjust audio settings here. Okay, then I switch to the program. And the first question is, when I click on a free space in the work window, I'm used to the selection being deselected. For me, however, it remains. What am I doing wrong? Okay, it means when I select, for example, this pipe, and with the control key, I can add in another pipe, and I can deselect it with the shift key. But when I click in the empty part of the window, then it is no deselection. And what is going wrong? If the user forgot to deselect this function here, add to selection, then that happens. And now I can, if I deselect it, and I can click here, and it works. It is selected, or you can see that it is selected, that there's a blue background here. Okay, I would like to show you some other features, how you can select things. For example, the circular ring. When we view in set direction, just a moment, so, and I use the wireframe model, then you can, for example, click here and so, and you can select the ring, and not the middle line, for example. So I deselect it, and you can also select, for example, with this function, with the lasso. So and you can select the whole pipe. Only that you know that there are such functions. Okay, that should be all to this question. And the next question is, how can I intersect two surfaces in RFEM 6? Now that's quite easy. I can remain by this example. I select all, and then with a right click, I can go to surfaces and create a divide by intersection. I divide the surfaces by intersection. So now we turn to the navigator data and the surfaces, and you can see where are trimmed surfaces have been created. and you can select them, and you can, for example, select these two parts of the intersection and delete them with the delete button. So, and now we can take a look through the pipe. Okay, so I would like to show you another option. I press undo again. So, and when I select all, same procedure, right click, surfaces, you have the option divide by intersection and create openings. So, and now we have only 4 trimmed surfaces. And you can, for example, delete this part, and you can take a look through the pipes. And then you can add your loads and supports and so on, create a mesh, and all should work. Okay, that's all for this question and for this model. I turn to the next model. So, and the question is, I have defined a line release with failure in vertical direction. Nevertheless, the connection in the direction is, in this direction is rigid. How do I enter the line releases in the correct direction? So we have prepared this model here, 2 parts of concrete surfaces, and this surface should be lift up when we have got such a load. We call it test load lift up. Let's calculate it. So, and we can see there's no global deformation. That doesn't work. If I double click on the line hinge, we can see in set direction, a nonlinearity is defined, and a small spring constant that it calculates. So fixed if positive we set. But the line hinge has got his own coordinate system. You can see that when you move with the mouse over the line hinge, or you can go to your left at the bottom, navigator display, then types for lines, line hinges, and then you can display the line hinge axis system permanent. So, and you can see the Y direction is in direction of the global Z axis. So that means that we have to modify this line hinge. So I deselect it in Z direction, select Y direction, add a small spring constant, and the nonlinearity fixed if positive Vy. Okay, and now we calculate all again, or at least the load case, the test load case. Okay, and now it lifts up. It must be clear that the line hinges have got their own coordinate system. Okay, so that should be all from my side. I take over or hand over the screen and the words to Jürgen. Jürgen, you can start your presentation.
Yes, thank you, Andreas. So I will be starting with the 3rd model for today and the 4th question. And the question is, how can I share my user-defined blocks with my colleagues? So first of all, if you don't know what are blocks in RFEM, I go to the Dlubal Center, which is the big blue D with the small white C in it. where you can, of course, navigate through your whole projects. You can check your personal Dlubal account, and you can also manage all your templates and blocks. When I go under blocks, you will see several parametric blocks which you can use in your model. Maybe some 3D holes there are for use in an RFEM model. Okay, but you cannot only use those pre-prepared blocks that we offer with the program installation. You can also save existing models and use them as blocks for further usage. So I have an example here, which is a steel column base, which is quite elaborate to model with all the details. So I want to reuse this again and again, and therefore I want to save it as a block. So I go to the menu File, Save as Block, and then I get to a saving dialog where I can give this one a name. Let's make it a name that stays in mind, like my foot. So this is my personal block now. I can give this a categorization and a model category to have a sound filter of it. So I go to the steel structures. They are here, and I go to the columns. So I have the column foot under the section columns in my model categories. Okay, I save the block, and this is now saved in on my computer on my local working directory. So within the model I'm using now, I can reuse this block now, either again via the Dlubal Center or right next to it via the block manager. So there you have the same block manager as in the Dlubal Center, where I go to the steel structures, to the columns, where I immediately find this block, which I have just saved with the name my foot. I double click on that block and get to a dialog where I can insert this block into my model. I'm just picking another point in the model, maybe over here, 10 meters from the first foot. When I hit OK, the block will be inserted. So this is one way to use those blocks, but the main question, as you remember, is how can I share those with my colleagues? So I go back to the Dlubal Center. In the section blocks to steel structures and columns. And when I do a right click on this block, I get the context menu where I can open the file location. So this is the folder where I find the working directory on my computer. I click on it, and in the Windows Explorer, I go up a few steps where I'm in the general working directory of RFEM and all the Dlubal products, which are under C, users, your personal username, app data, local Dlubal. This is where you can find all the temporary data in which are used by the Dlubal software from the current program generation. And there I go to Dlubal Center, blocks, user blocks, and this is where all the user-defined blocks are saved. You can see I've saved a few more. So to get to the one I have just created, I can either go to the user blocks XML. I open this in my default web browser, and then I can search for my foot using Control and F for the search function, as you know. And then I find the block with the name my foot, and this is this line in the XML file. And there you can see this ciphered name, which is in fact the name of this block as a data file. So when I go back to the Dlubal Center, you can also see this encrypted name, which is the one for my foot. So in the Windows Explorer, this file is exactly my block, and you can copy this to any place you would like. You can email this to your colleagues, and then they can reuse this block either just as a file. So this is just a simple RFEM model file. So when you share this, I double click on it directly from this working directory, and I open, oops, I want to open it in the English version, which is the one I have here. I open this block now as a RFEM model file. You can see in the name this encrypted file name, and once your colleague who you've sent this block to has opened this file, he or she can perform the same as I showed you previously. Go to File, Save as Block, so they can have this block in their own local working directory and in their own Dlubal Center. Yeah, that's for sharing those user-defined blocks. I will go to the next model for today. And the question about this model is, why can't I mesh my ceiling with downstand beams? So we now have here a single span ceiling with 2 downstand beams integrated to it. And when I say, computer, please create my mesh, I will run into an error message about an error during the mesh generation. So I need to check, what is this about? At first, I would like to hide those beams. Go to the navigator display and hide my members, so I can analyze the lines on which those members are based on. The right one is a typical line from node A to node B, which is okay. And the other one is line number 5, is a polyline, which has 4 nodes in it. I double click on it. You can also check that this line contains 4 different nodes. And the problem now is with a downstand beam, which is a member of the type rip. There is an inconsistency of the topology of the model when you want to have this downstand beam, which goes from node number 5 to node number 8, and the computer needs to calculate the effective width from which the surface internal forces are integrated into member internal forces when there are these 2 intermediate nodes interfering with the line. So in a straight member, you wouldn't be able to tell the difference at first, but when I say I will move this node a bit to the left, and then we get this double kink into this downstand beam, then you would say, okay, now it's impossible to calculate any integrational width from this rip type member. Okay, so now this is the problem. How do we solve it now? I can give you 3 different ideas for a solution. The first one would be if I edit the member on the left and say, now this is no longer a rip type member, this is now a beam. I say, okay, So you can see the first disadvantage, I have deleted my eccentricity. However, it's pretty simple to get an eccentricity manually into this beam. When I double click on it, go to eccentricities, there's another tab, and then I create a new eccentricity for this beam. Say the top of this beam, the plus Z side, needs to be set relative to the minus, the downside, the plus Z side of surface number, I pick it in the model number 1. And also get the same eccentricity to the end of the member. So now we have the member with the correct eccentricity, and I can create the mesh for this model. Okay, that would be one solution. However, when you do this, you lose the integration width to this downstand beam when you don't use it as a rib. So I undo my changes. I say that's not a good solution. It's a solution, but there are better ones. I undo to the first configuration, and now I can go here to these nodes, since I have identified them as causing the problem with this polyline. I simply delete them. So now you see it's still one member that goes from node 5 to node 8, but there are no intermittent nodes which interfere with my rib type member. So this is also another possibility to generate the mesh for this model. Okay, then you can say, well, this might be good, but I needed those two nodes for loading points to maybe get nodal loads on them, or maybe connect something from the top here. And so this is not the perfect solution for me still. I undo this to get those two nodes back. And what I do now, I right click on this member. I edit the line of it, this mentioned polyline of 4 nodes. And when I edit the nodes, I can deselect those intermittent nodes. So pressing Shift, I deselect both, and this polyline now goes from node 5 to node 8 without any intermittent points. And when I generate the mesh, you can see that this small modeling error I have made in the first is now corrected. Good. Now we come to the last question of today, and therefore I go to the last model of today, which is a steel hall. And the question for this model is, how can I conveniently save detailed views of the design types I have entered and use them as a template in the printout report? So this question comes when you have structures like this and you want to perform a stability design check for all the members. So in the steel hall, I want to use the equivalent member method for the stability design of my columns and for those green coupling beams. Therefore, I have edited the effective lengths. When I double click on one of those columns, you can see under the design types that I have edited one effective length, which I want to use for all the members I want to design with the equivalent member method. So now I have the visualization of these in the lower part of my dialog, and I can also use this button with a bent beam, which symbolizes the actual view of this member now as it is in the current view of our whole model. And I can print this one, or now I have the opportunity to print it to a graphic template. So I do this now. I select a name. So this is for the effective length. So I name this effective length. Say OK. And with the dialog. So that's all I've done for this effective length now for further use in the graphics. The horizontal beams, I have defined sets of members, and there are tapered parts in these members, so I cannot use the equivalent member method for those. And now I want to use the general method for the stability design check. Therefore, I have edited the boundary conditions for these sets of members. So I go to the types for steel design. I go to my boundary conditions, and there we have the two boundary conditions. I'll show you the first one. So you have the different, go to the dynamic view of those in the model. So we have the fork support at beginning and end of those sets of members and lateral supports in the intermediate nodes. Okay, and to get to the graphics, I'm going to open one of my member sets, go to the design types, and there you can see the visualization again of the boundary conditions here. Again, I click to the symbol with this bent beam, so it is the dynamic view which I've used now in the other graphic template. And again, instead of creating a graphic for each and every one of those member sets, I just click once to print as graphic template. And this one I will name BC for boundary conditions. Okay, now I have created those templates, and you might wonder, where are they now? What are the benefit of this? And I click in the menu options to find the graphic templates. There is a list of graphic templates I have in my model in my current program instance. And when I want to reuse them, I go to the graphics print. So I have not yet made a printout report. I will create a new one. But when I want to print the graphics to the printout report, I will use the multi-print option. So at the current setting, I will only print one graphic. In Window to print, I go to multi-print. And then I go to the tabs on the top, so I can print several directions, several sides of my model, which I'm going to skip today. Also the loads, you can print a graphic for each and every load case in your model into the printout report all at once. But I'm also going to skip this today because I want to focus on the graphic templates. So I check templates, I check effective lengths. This could give me easily 126 graphics now, but I want to keep it short. So I go to the select section, and with the picking arrow, I pick the members I want to print from a template in the model. So I empty this selection and say I want to use the column on the outside and the center columns, and of course those coupling beams. So I have a representative for each and every one of these members I want to design with the equivalent member method. Say OK. Then I go to the next graphic template, which is the one I called BC, and also don't want to print it out for all 7 of my member sets, which could easily be done. But I select again, and using the outfield member set, empty selection again, using the outfield member set and an infield member set. I go to OK. I have 6 graphics to print. And when I go to General, I get a preview of my graphics. And this is now on full screen. We can adjust the height. If we go to the graphic picture size, skip from full page height to a height of, let's say, 45% of the page height. Just takes a few seconds to synchronize the preview. And also there's this color scheme, the color panel of the rendered objects. When I scroll down, I can also deselect this function. Need to sync. So we get the actual preview. And now you can see the preview of the effective lengths for the coupling beams with an effective length of 5 meters and the length of the columns with 6 meters. And again, 6 meters and 6 meters. And when I scroll further down, you can see the boundary conditions for those horizontal sets of members with all the lengths of the single fields within it, and also for the infield sets of members. Okay, when I go to Save and Show, now I create a new printout report. So I just make this really short. So we have basic objects, materials, sections, nodes, and members, and hit OK, and the program will print these graphics at the according point of this really short printout report I'm creating here. Yeah, you can see under the members, you can see the graphics for these design types for the members. Here you have them all printed conveniently within one brush. Okay, so that's the function of the graphic templates. Just try it out, have fun with it, and let yourself be surprised. I thank you for your attention and would like to give the control back to Andreas.
Okay, thank you, Jürgen, for this presentation. Yeah, we record our webinar. Yeah, we record all our webinars, and we offer the models that we presented on our website. I would like to show you where you can find the recording, or where will you find the recording in the next days and the models. I share my screen. Just a short moment. So before I show you the website, just a small hint, you can book your free online appointment, such as a product demonstration of an add-on of our program and so on. Yeah, if you wish that, then just contact our sales team. You can click that link here, or you can scan that QR code. Okay, I turn to the website, dlubal.com, and under news and events, you can find the webinars. Those are the webinars of the next weeks. Next week, about our add-on building model, then connection design according to American standard, construction stages and membrane structures, cross-section modeling in our section, and so on, construction stages. Then the next webinar that we presented today, yeah, in that case for May. So then I will present that webinar about the modeling and design of steel structures. It is a two-part webinar. If you are registered for our newsletter, you will get an invitation before that. So that's today's webinar. I click on it, but you will get an email in the next days with a direct link to that page here. And then you will find the recording here. You will also get the attendee certificate. So then you will find the PowerPoint slides here, and you can already find the models to download. And then you can go through the webinar with the provided models and the recording. Okay, that should be also all from my side. Thank you for your attention. Thanks to Jürgen for his part of the presentation and for answering the questions. I wish all a nice rest of the day. I hope we meet each other in a future webinar. Bye-bye.